Hello, this is Noman from the Department of Electronics and Telecommunications, Politecnico di Torino. Today I'm going to present my PhD research work, and that is electrochemiluminescence devices based on novel materials for biosensors. My PhD work has been supervised by Professor diTorino, and it has been funded by Higher Education Commission, Government of Pakistan. Well, before going into technical details of my research work, let me share something with you. It was indeed quite a long journey from a toothpick to a doctor of philosophy. And when I'm saying toothpick, I really mean it. At the end of my presentation, I'll show you that the most significant results during my PhD were obtained by using these toothpicks. As far as ECL is concerned, it is a process where electrochemical energy is converted into radiative energy by or through electrochemical reactions. The most commonly used ECL system consists of tripropylamine as a co-reactant and ruthenium trispipyridyl as a emitter. So what happens here is when we apply a voltage across the electrodes, there is a transfer of electrons take place. There is a redox reaction between the electrode and the solution, which consists of ruthenium and TPA. What happened here is, in the process, ruthenium and TPA got oxidized. Then this TPA loses a proton, serving as a reductant, and it enables ruthenium to go to its base state while emitting a photon. The ECL system is basically consists of 3 electrode configuration. Throughout my PhD work, we have used silver chloride as our reference electrode, gold as our counter electrode, and we have used different kind of novel materials for our working electrode. So my objective was to figure out highly efficient, cost-effective, and environmental friendly sensing material for biosensor by using ECL technique. In order to doing so, we have used many novel materials during my PhD, starting from the carbon nanotubes to carbon fibers, from gold nanoparticles to bismuth. But I will not go into details of these materials due to time limitation. Rather, I will focus more on the most interesting part of my presentation, and that is biomass materials. As you all know, biomass materials are rich in carbon, and hence they are intrinsically biocompatible. We have used 2 biomass materials, bamboo and pistachio nut shells. In the beginning, I told you that the most significant results during my PhD were obtained by using these toothpicks, and here they are. These toothpicks are made of bamboo, which we have used in our analysis. So here how we have made the working electrode out of these bamboo sticks. We have used the bamboo sticks, we pyrolyze it, and then we have made the working electrode. Similarly, we have synthesized the carbonized pistachio nut shells, and after performing certain steps, we have made a working electrode out of these nut shells. Well, in the beginning of my presentation, I claimed that the most significant results during my PhD were obtained by using toothpicks, and here they are. If you can see the figure 10, the ECL emission obtained by the pyrolyzed bamboo are quite high. Also, they are much more stable in time. If you can see the phase image of pyrolyzed bamboo, you can see the variation in pores from maybe 100 of nanometers to 10 of microns, and actually they plays an important role in enhancing the total ECL emission as well as the stability. If we compare it with the traditionally used glassy carbon, you can clearly see that the ECL emission with the pyrolyzed bamboo is far more better than the glassy carbon. Also, it is much more stable in time, and on top of that, they are low cost and environmental friendly. The only problem with this kind of material is the reproducibility. If you can see the figure 13, We have used 10 different pyrolyzed bamboo electrodes, and we have tested 5 different times, but even they are not reproducible. The total ECL emission are even higher as compared to the mean of glassy carbon. So it seems that the objective has been achieved. They are low cost, they are environmental friendly, and they are very efficient as well. Similarly, we have obtained some very decent result with activated carbonized pistachio nut shells. Not as good as we have with the bamboo, but it is even comparable with the glassy carbon. It is quite stable in time, and it is comparable to glassy carbon. Also, they are suffering with reproducibility, but our intention is to make low-cost devices and disposable devices rather than the analytical applications. So it seems that the objective has been achieved here as well. So the conclusion is we have used different kind of novel materials, low cost and environmental friendly factor is there. Even they are lacking good reproducibility, but our intention is to make low cost and disposable working electrode rather than to use it for analytical applications. So these are the selected publications, and thank you very much